The first light of dawn spills over the northern Cambodian plain, catching the 5 iconic lotus towers of Angkor Wat. For centuries, this has been the defining image of the Khmer Empire. A breathtaking stone temple mountain, emerging from a sea of impenetrable jungle. Its perfect symmetry, the vast moat reflecting the cosmos, speaks of a civilization at the apex of its power and piety. But this image, as magnificent as it is profoundly misleading. It presents us with a masterpiece of architecture, yet hides a far greater masterpiece of engineering. The real story of Angkor is not just in the stone we can see, but in the landscape we cannot. How did a city of nearly 1 million people, the largest pre-industrial metropolis on Earth, thrive, build, and innovate in a climate of extremes, swinging violently between torrential monsoon rains and devastating drought? That is the central puzzle. Now, let's open the field reports and reconstruct the systems that powered the ancient
Investigation.
When we
Angkor.
look at the archaeological maps from the 20th century, Angkor appears as a scatterplot of monumental sites. Angkor Wat here, the walled city of Angkor Thom there, the Temple of Ta Prohm, famously gripped by the roots of silk cotton trees further east. For generations, we saw these as discrete ceremonial centers, connected by rudimentary roads, all surrounded by a vast, untamed wilderness. It was a vision of isolated grandeur. The physical evidence on the ground seemed to support this. We could trace the enormous moats, marvels of excavation in their own right. We could stand on the edge of the West Barai, a colossal man-made reservoir measuring 8 kilometers by 2, capable of holding over 50 million cubic meters of water. These features were so large, so audacious, that their purpose was debated for decades. Were they purely symbolic, vast cosmic oceans designed to mirror the heavens and legitimize the king's divine status? Or were they functional pieces of a citywide infrastructure? The problem was, the numbers didn't quite add up. A population estimated between 750,000 and 1 million people requires a staggering amount of resources, primarily water and food. The
Disconnected
visible
system.
canals and reservoirs were impressive, but they appeared disconnected, unable to form the coherent, city-spanning logistical network required to manage the monsoon's deluge, and then distribute that water through the months of parched, dry heat. Supporting a capital city larger than modern-day San Francisco with these disjointed pieces of engineering seemed like a logistical impossibility. The traditional archaeological approach, painstaking, ground-based excavation, provided invaluable detail, but a limited perspective. Digging trenches in the dense, mine-strewn jungle is a slow and dangerous process. It yields localized snapshots. The foundation of a house here, a section of a road there. It was like trying to understand the design of an entire microchip by examining a single transistor. For decades, the true nature of Angkor remained obscured by the very ecosystem that had reclaimed it. The forest floor, a tangled mess of roots, soil, and centuries of decay, held the city's secrets tight. Researchers knew there had to be more canals, more agricultural fields, more housing. But the sheer scale of the jungle made a complete survey impossible. We had found the temples, but we had lost the city that sustained them. The greatest challenge was not one of interpretation, but of vision. We simply couldn't see the forest for the trees. To solve a puzzle locked away by a forest, we needed a way to remove the forest without touching a single leaf. For centuries, this was pure fantasy. But in 2012, an international consortium of archaeologists, led by Dr. Damian Evans, deployed a technology that would fundamentally rewrite the story of Angkor. They mounted a sophisticated LIDAR system to the belly of a helicopter. The acronym stands for Light Detection and Ranging, but its function can be understood more simply. It is a tool for creating an astonishingly precise, three-dimensional map of the ground, right through the densest vegetation. As the helicopter flew in a meticulous grid pattern over the greater Angkor region, the instrument fired billions of laser pulses downwards. Most of these pulses would strike leaves and branches, bouncing back immediately. But a crucial fraction would find their way through the gaps,
Ground
hitting
return.
the forest floor and reflecting back to the sensor. The initial result of this survey was a gargantuan digital file, a point cloud containing the precise coordinates of billions of individual data points. In its raw form, it showed everything: the majestic canopy of the jungle, the temple towers, and hidden beneath it all, the subtle topography of the ground. The next step in our digital investigation was the critical one. By applying sophisticated algorithms, we can filter this data, telling the computer to digitally strip away every data point
Remove
returned
vegetation
by vegetation.
returns.
What remains is a bare earth model, a ghostly, high-resolution image of the landscape, as it would look if every tree and shrub were to vanish instantly. When the team finished processing the 370 square kilometers of the initial survey, the image that emerged on their screens was nothing short of a paradigm shift. The myth of the isolated temples in the jungle evaporated in an instant. Where the maps had once shown green voids between the major temples, the LIDAR data revealed a landscape completely transformed by human hands. A vast, low-density urban sprawl emerged, laid out in a sprawling grid. We could see the faint, raised earthen mounds where countless family homes once stood, each with its own pond and garden plot. We could trace the paths of ancient roads and the outlines of entire neighborhoods. But most importantly, the data uncovered the system that held it all together: a water network of breathtaking complexity. The disconnected moats and borees were revealed to be just the largest, most visible components of a single, integrated hydraulic machine. Countless smaller canals, channels, dikes, and embankments crisscrossed the landscape, connecting households to neighborhoods, neighborhoods to districts, and districts to the colossal state-managed reservoirs. This was not a city that happened to have water channels. This was a city whose very urban fabric was defined by water management. The scale was almost incomprehensible. The survey revealed a geometric grid of canals and embankments stretching for dozens of kilometers in every direction, far beyond the walls of Angkor Wat. The entire landscape was an engineered artifact. The system was designed with a dual purpose, perfectly tuned to the monsoon climate. During the wet season, the network would capture and slow the torrential runoff, preventing catastrophic flooding and directing the excess water into the massive barrages for storage. Every component, from the smallest household pond to the largest state reservoir, was part of this citywide flood control system. Then,
Dry season.
during the months of drought, the flow could be reversed. Sluice gates, the
Distribute.
remains of which have been found by archaeologists on the ground, would be opened, allowing the stored water to be systematically distributed back through the network for irrigation and domestic use. The LIDAR data showed us the ghost of a civilization that had turned the very challenge of its environment into the engine of its prosperity. We were looking at the circulatory system of a metropolis, a system that had been hidden in plain sight for over 500 years. Reconstructing this hydraulic engine from the LIDAR data reveals a level of engineering sophistication that is staggering. The Khmer engineers were masters of topography. The The Angkor Plain has a very gentle, almost imperceptible natural slope, running from northeast to southwest. They exploited this gradient with phenomenal precision. By building a vast network of feeder canals and diversion channels, they could intercept water from the rivers flowing down from the Kulen Hills and guide it across the landscape. The entire system operated on gravity alone. It was a delicate, low-energy solution to a high-stakes problem. This intricate control allowed them to support a revolutionary form of agriculture. Instead of relying on a single rain-fed rice harvest, the Angkorian system guaranteed a steady supply of water, enabling up to 3 harvests per year. This massive agricultural surplus was the foundation of the empire's power. It fed the armies, the administrators, and the hundreds of thousands of laborers who quarried the sandstone, carved the reliefs, and raised the temple towers to the sky. The city's wealth was not built on gold, but on water, and the logistical genius required to manage it. But a system so exquisitely optimized for a particular environmental rhythm is, by its nature, incredibly vulnerable to changes in that rhythm. Here, our investigation turns from laser scans to climate science. Analysis of ancient tree rings from Vietnam and sediment cores from the Angkorian berets themselves provide a clear, dated record of regional climate. The data points to a period of profound instability beginning in the mid-14th century. The consistent pattern of monsoon and drought that had persisted for centuries broke down. What followed were decades of extreme weather. Theory. The climate record suggests a series of prolonged, punishing droughts lasting years at a time, punctuated by sudden, violent mega-monsoons. For Angkor's hydraulic machine, this was a death sentence. The long droughts would have exhausted the vast water reserves and berets, causing widespread crop failure and threatening the city's food supply. Then, the intense deluges that followed would have been too much for the network to handle. A system designed to manage predictable runoff was suddenly hit by a volume and velocity of water it was never built for. Ground-based archaeology corroborates this, revealing evidence of canals being violently scoured out, embankments breached, and the entire system suffering catastrophic, cascading failures. The very infrastructure that had guaranteed Angkor's prosperity became an agent of its collapse. Faced with a failing logistical backbone and increasing pressure from rival kingdoms, the Khmer elite began a gradual relocation south, and the great city of Angkor slowly succumbed to the jungle that had always been waiting at its edges. The story of Angkor, revealed not by the spade but by the photon, is a profound testament to the delicate balance between human ambition and the natural world. It reminds us that the greatest monuments of a civilization are often not the temples they build to their gods, but the unseen systems they engineer for their survival. Through the lens of modern science, we can finally read the ghost of this magnificent city, appreciating the ingenuity that gave it life, and understanding the forces that brought about its end.